Station 51, Engine 27, Engine 32, Truck 105.
You're listening to The Fire Break with Steve Wolf. Hello and welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire, developing innovative fire control methods. Check us out on the web at teamwildfire.com. So, what was the idea with the original Team Wildfire technology? It was to take an airstream and point it at fire or in front of fire and use it to apply retardants, water, whatever it takes to, manage fire. Well, guess what Wayne Darnell came up with? The exact same idea that he went about in a different way. I went with jet engines, and he went with the giant fans from fan boats. Wayne, this is a pretty fascinating coincidence here, isn't it? And welcome to the Fire Break.
Thank you. Yeah, it is quite a coincidence.
So, where did this journey start for you?
Well, I guess it was around 2018, actually. I had a patio grill that didn't ignite. The igniter didn't work, so I used matches, strike anywhere matches. And I took two out. It usually takes two. It only took one this time. I thought, I'm not going to take this second match back into the house. So I struck it, and as soon as it burst into flame, I blew on it. And I started to throw it away, and I looked at it, and I'm thinking, like, geez, where my breath hit this match head, it didn't burn. On the back where it didn't see the wind, it did burn. And then I started looking up the ingredients of a match head, and it's some combination of phosphorus, sulfur, and potassium, which is designed, obviously, to burst into flame. It takes about 400 degrees for it to light. It burns at about 1400 degrees, which is a standard kind of common wildfire temperature. Some of them get like much higher, but 1400 is kind of the standard. And I'm thinking, like, if my breath can do this, then maybe more breath or more wind could do the same kind of an effect on a fire. So I started looking into it and look at different options that I might be able to use for the wind. And I could get the biggest bang for my buck if I went to the airboat type fan apparatus that they utilize to propel the boats across the water. The industrial stuff was heavier. It took a lot more energy. It didn't put out as much. So I got higher velocity, higher volume with the airboat design, and that's what I went with.
Okay, so who did you first tell this idea to? And then how long before they stopped laughing?
Very first, yeah. Well, they're still laughing.
Okay.
The first person, I'm not really sure. I guess I started looking around in the local fire stations around the city, and I got some interest from the people who were the firefighters. So when I started going up the ladder and trying to reach out to the people who could maybe make a decision or held a checkbook, there just wasn't any interest, and they were talking about what I couldn't do with it rather than what I could do with it. And of course, like any firefighting device, there are limitations. There will always be issues with the type of fuel, the terrain, and the weather conditions. But I think that this could be a significant complement to what's already out there in the field, just as your machine is. It's very versatile. You can put it on just about any machine. Right now, it's not totally it's not powered by itself, except for the generation of the wind. So we use transport vehicles. And right now, the next time we do testing, I want to use a front loader, which can give us about a 23 mile an hour velocity. So it's pretty versatile, pretty quick. So it can get around the fire and the flame front and position itself appropriately. And we're just trying to influence the flame front. I mean, we're not changing the weather, but we can change the wind conditions at the flame front, and that's where we need to be. That's where the action is, and that's where we can make a difference.
Yeah, we're singing out of the same book here, I think.
Yeah, we are indeed.
Right. We are changing the weather, but just not over a large area. We're just changing that microclimate where fuels are being converted to oxidized fuels.
Right.
Right.
Yep.
Change the wind direction, push the flame tips back over.
That's the
effectively
idea.
Strip away the heat. Yep.
Bending the fuel. And high wind does a lot of interesting things that I've found out when there is a flame front. Obviously, you can bend the fuels back over onto the burnt area, so you're depriving the flame front of new fuel to burn. But if you have a high enough wind, you can also get what they call flame separation. You can get boundary layer disruption, and actually even inhibition of oxygen utilization, because the oxygen has to be there for a certain period of time for it to actually support the combustion. So those three other things are going on in addition to just bending the fuel back, and the cooling capacity is significant too. 1 cubic foot of 700 degree air, which is the maximum temperature usually to ignite any kind of wildland fire fuel, can be reduced to below 350 degrees, which is the minimum temperature for some wildland fuels, with just 2 cubic feet. This machine puts out 5,500 cubic feet per second, so 337,000 plus cubic feet per minute. So there's a significant amount of cooling in addition to the effects of just a high velocity wind traversing across the flame area.
So it starts with the idea, right? What this thing's going to look like and how it's going to act. And then you have to go back and study the science to justify this idea, right?
Right.
So somewhere
Exactly.
subconsciously, your brain knew this could work. And then,
well, I hope so. I mean,
yeah,
now
right.
that I'm
Well,
consciously thinking about it, I do believe that, yes.
yeah. Okay. So where did you go for prototyping? How did you start that process?
Well, I sought funding from over 100, I guess, different possible options. No one stepped up. It's brand new. You know how that goes. There wasn't a whole lot of interest. Innovation is not always welcomed with open arms. So I decided to put my money where my mouth was and use my own resources to develop and produce the first prototype. So it's the only one I have right now.
And so what did that end up costing?
Well, just the hardware and the labor and stuff, a little bit upwards of 60,000.
Okay. So for, a business startup, that's not a huge amount of money.
No, it isn't. But I mean,
Right.
of course, then after that, I had to find a crew to do this, find a crew to do that, find a place to do the testing, ship
Right.
everybody out there, bring everybody down, support their stay. You know how that goes. So,
Yeah.
I
It
would
gets
say,
expensive.
yeah, I'd say at this point, probably, and then it's patented also. I got 2 patents on it. It's over 100,000.
Oh yeah, easily.
Yeah.
I mean, you could spend that just on the patent, right?
Oh yeah.
So where did
But
you go
but I
for
did.
testing? And did they let you do some live fire testing?
Yes, I went to Tall Timbers Fire Research Station outside of Tallahassee, Florida. Thanks to the help and the support that I got from Dr. Rod Lynn. He is a fire modeling computer expert at Los Alamos National Laboratory. And he's on the board at Tall Timbers. And I hope I'm not stepping outside of the bounds of what he's supposed to be able to do and not do. But being on the board, he was able to get me a time spot there at Tall Timbers just for a day. We just tested for part of the morning. And it was conditions that were not conducive to propagating a flame front, but we were going to do a prescribed burn. Humidity was above 65%. We had just had a morning shower that lasted for a while, so everything was wet. Nevertheless, we did the drip torch fire line. We didn't do a good job of separating the test area from the control area, but within about a 19-minute time frame, we propagated the flame front about 118 feet, whereas the local one, the control one, which actually I think was aided a little bit by the wind stream that we were generating, went 24 feet. So we did about 5 times the distance in the same time frame compared to what natural conditions would have allowed. And we were only using about half of our velocity. Rather than blowing it out, we wanted to propagate it, so we kept the wind speed down. We probably could have increased it a bit more and gotten more of a propagation rate, but I think that the results were sufficiently convincing to show that this is something that could be useful in the field.
Right. And the question then would be whether you could propagate a flame front in the face of adverse winds.
Right. Well, actually, that's the other thing that I didn't mention because it wasn't all that great, but we did have a headwind when we were doing this. So it's kind of a backburn kind of situation.
Okay. So in real life, that adverse wind might be driving a big fire towards you,
right?
In which case you'd want to light a little fire in front of you and push that fire forward. And
yes. Do a backburn kind of
create
thing.
that backburn.
Yeah, and with this device, you would be burning less unburnt land. You could start closer to the flame front, burn it faster, and save some of the land that is in vacuum now that would have normally, if you were just using natural conditions, would have been necessary to ignite.
I've never seen a circumstance where a backburn or prescribed burn of any type had any long-term negative effect on the land. I mean,
no.
When I lived in Texas, I burned my land off at least twice a year.
Yeah.
And so I wouldn't think of doing that as damaging the land. It comes back greener and stronger.
It does, but if you're just addressing like a wildfire, like a forest fire, and you just want to get a back burn area, it's just a possible savings if you're interested in doing it. But you're right, it rejuvenates the land basically if you do it appropriately. And there are currently about 200, maybe probably at this point more than 235 million acres in the United States that are in dire need of prescribed burns just to avoid catastrophic wildfires. I mean, we're not keeping up with it. And that's a repetitive thing. Like you said, you burned, what, twice a year or every 2 years? Something
Twice
like
a year.
that. So this is something that needs to be done on a routine basis. It's not a one-time effort. Needless to say, there's a lot of opportunity seemingly there for just a prescribed burn, even though with the high velocity, high volume targeted airflow, we can do some extinguishment as well as propagation of the flame.
Yeah, there's a lot of land that needs to be burned, and there's a lot of wisdom about how to do that, right? There's a lot of indigenous culture wisdom. Yeah, I would sometimes just look over at my TS4000 torch, and it would just start calling to me, and then I would, he'd say, "Pick me up, take me outside," and I would, and then I'd start lighting fire, and then about an hour into it, I'd realize, oh, I guess today's a prescribed burn day.
Yeah. Whether you like it or not, but your land is happy. It's happy to be there and have you do that because it really is a rejuvenating thing.
Yeah,
you're
really
not ruining anything. You're actually, and it's also when you do a prescribed burn, you're killing a lot of pests that otherwise could maybe attack the other flora in the area. We have bark beetle situation here in New Mexico, and it devastated our pinon trees. In the area where I live, we had to cut down thousands of them that were destroyed by this. And doing a prescribed burn in that area would have probably inhibited the growth and the infestation degree to which we experienced this need to chop down all these trees. It was really a shame. But they show up periodically, and a prescribed burn in the same area where these things exist would actually cut that down quite a bit.
So when they cut down all those beetle-infested trees, if they stack them up, burn them, what do they do? Because I would imagine that if they're burning them, that's a pretty dirty fire. But if they were to bring your fan over there and you were to just feed the right amount of oxygen, not blow the fire out, but that you could actually make that burn much more efficient and cleaner.
Oh, sure. Yeah, we chopped them all down. So I don't even know what the end result was. I think we might have mulched a number of them, but I don't know if that kills the bark beetles. So I don't know what they did with the mulch if they mulched them. But we lost the carbon sink because the trees are now gone, and now we're going to possibly burn them, burn the dead trees to put all that CO2 that had been stored now back into the air.
Not the best plan.
Not exactly. No. Yeah, we got enough CO2 in the air for sure.
Right. Now, when you mulch the trees and then they decompose on their own, does the carbon stay local?
I honestly don't know. The bark beetle infestation that we experienced happened shortly after I got into the community, and I wasn't here on the whole idea of carbon sink and my concept until some years afterwards. So I didn't really follow the whole track. But if it's dead plant matter, I mean, ultimately, it's not going to stay in its solid form. It will eventually off-gas to at least some degree and put some of what had been stored back into the atmosphere for sure.
Yeah, I don't know whether decomposing soils or decomposing wood releases gases or whether it just the carbons all get absorbed into the soil.
Yeah, that's beyond my...
Somebody knows.
Yeah.
Somebody knows.
I'm not
Somebody listening to this show knows.
Probably.
And I hope they'll drop us an email or shoot us a message on LinkedIn and tell us.
Yeah. That's not part of my understanding, so I really didn't follow the whole cycle. But generally, that's kind of what happens whenever you chop down a tree. It's not get properly utilized to be totally integrated back into the soil and not release anything into the atmosphere.
Yeah, so, or if it does, at least it's releasing it at a much lower rate.
Right. Yeah.
The rate of decomposition instead of the rate of conflagration.
Yeah, there's a big difference there. I don't know completely. What the rate is, but it's a bunch. It's high.
So what were you doing before this 2018 barbecue incident?
Well, prior to that, I had been employed at Los Alamos National Laboratory. I guess for about the last, had been about 15 years, something like that. Before that, I did commercial nuclear power plant startups. And before that, I was in nuclear submarines. I was in the Navy and working aboard
Thank you
the
for your
submarine.
service.
Yeah, thank you.
And what did you do at Los Alamos?
A variety of things.
This and that?
Beg your pardon?
I said this and that?
Yeah. Well, I first it was just operation support, and then I got into packaging and transportation of nuclear materials. Then I got into doing facility assessments just across the laboratory, different places, generally looking at either safety basis, engineering, or training kind of stuff. There were different areas that different people had different expertise in. So we would just go through the whole laboratory over a period of time and do assessments that the laboratory supported, and the individual facilities weren't particularly welcoming to our presence, but it was a requirement, so they tolerated us. And then I did some training also in safety basis stuff. It's called the unreviewed safety question. It's a Code of Federal Regulations requirement that is imposed on nuclear facilities.
I see. And tell me about the patent, because if you go to an event like FDIC, the big fire department conference, you'll see a variety of tangentially related technologies to what we're doing.
Mm-hmm.
Right? The electric-driven fans, gasoline-driven smoke ejector fans. Some of them, with misting nozzles on them. Right. So how do you find that unique bit that becomes, that takes you from the range of a good idea into IP?
Yeah, that's a lot of work, actually. There's a lot of time spent going through all the patents that are already out there, and going through just things that are commercialized and not patented. So, I mean, I don't know how many, at least probably a couple thousand hours, maybe, making sure that I was doing an adequate review of all those competitors, if you will, that are out there that I had to consider before I could write something to give me claims that were unique and set me apart from the other entities that were out there, some of them doing some of the same work like what yours is doing. But the fact that we're only using air, which is infinite resource, non-polluting kind of stuff, and we weren't using anything else that would possibly be an environmental hazard, or just from the standpoint of availability. If you're out in the field, in a wildland fire, you run out of water pretty quickly unless you have a steady supply. As long as we have gasoline in the tank that drives the driver for the air mover that we use, we're good. We tested for about 2 hours, I guess, maybe 2.5 hours at tall timbers. It certainly wasn't at full speed because it's a gas guzzler at full speed. It's 525 horsepower engine. But after testing about 2.5 hours, 2 hours, we used 5 gallons of gas. So we had about a 20-gallon tank. The idea would be to put a 40 or 50-gallon tank there. And of course, you'd have to insulate all, fire protect all this stuff, the coating and everything, and put a spark arrestor in the injectors for the engine. But that's all stuff that can be done. The testing that we've done so far was, very controlled. It wasn't really in some sort of hazardous condition. So we have to take extra steps when we put the final version of the prototype out in the field to do its job.
And is your system designed on strictly being airflow, or are you introducing things into the airflow?
Well, the patent does show a sparger unit around the circumference of the propellers, but I started calculating to change the moisture content considerably for 337,000 plus cubic feet per minute. I would have to inject a ton of water, and so that kind of takes away some of the desirability, I guess, of having this thing out in the field, depending on the water supply. So then I just started looking more at just what wind can do. Aside from all the things we talked about, just a high wind with the flame separation, bending the fuels back and stuff like that, there is a substantial amount of cooling. So I felt like this could stand on its own. And I think that was probably the thing that set me apart from so many other devices that are already out there or that were patented and not yet deployed in the field.
It's pretty interesting. I mean, the ultimate goal is to get it out on a live fire, right, and see what it does. Yeah. We had an unexpected opportunity a couple of weeks ago with the storm cell. and we were transporting it across the country and happened upon a 38-acre grass fire.
Told me that. It's
and we
unbelievable.
filled the tanks and started, pushing water at the fire. And then at one point, the water had run out. The jet was still on, and my brother was still driving, and he observed exactly the phenomena that you described.
Yeah.
That the jet alone was putting out the fire without the need to add water.
Frankly, I was surprised when I realized that, first of all, when I calculated how much water we would have to inject through the sparger unit to get significant change. I mean, just a humidity change, much less atomization like you have in your device. So then I started looking harder. So what if it were just air? And there's a substantial amount of cooling capacity right there. You're not subcooling anything, so you're not taking anything down to 212. You only need to get below 350 degrees. Air being what it is, as opposed to water, it's like 2% of the viscosity of water. So you can permeate a geometric configuration of any type of fuel type much more readily to get the air in there rather than worrying about the water. And you keep your motive force there all the time. When you hit it with water, it'll tend to evaporate, vaporize, and of course you get a lot of evaporative cooling as it transforms from liquid to gas. But you lose your motive force and just kind of will tend to rise with the hot air rather than continue to drive. And the air force, of course, will always be there. The wind direction and speed can be controlled all the time.
Hopefully,
yes. Well, it can be, but whether or not it's sufficient. I mean, certainly there'll be fires that you just need to get out of the way. You can't do much about it. You can attack from the sides and the back, but you can't get in front of a wildfire that's generating about 10,000 megawatts an hour. I mean, a trillion if you're looking at the whole thing, maybe trillions. So
I try not to look at the whole thing and just look what's the part of the fire that endangers us or impacts us or that we can impact.
Exactly.
And that's usually a tiny fraction of the fire, the fire line that could be hundreds of miles long.
Right. But if you get in there early enough, our machines can do the job before it gets to that conflagration that you just have to, get people out of the way of and just let it run its course, because there's nothing you can do about it when it gets so big.
So do you think that as we have more and more fires, it will create more opportunities for the current technologies to reveal its shortcomings and create a more obvious void for new technology?
Well, I hope so. I mean, necessity is the mother of invention, I guess. But I have not been happy, I guess, to experience what I have so far, trying to reach out to firefighting organizations with my idea. What few responses I have gotten, and mostly it's silence, but what few responses I have gotten, they're always looking at ways that you can't use it. Well, if we were in a canyon, you couldn't use this, and I write back and say, yeah, you couldn't get a man down there or any other type of device either. And aerial assault, as you know, has its own problems. Sometimes you can't get up there because of weather conditions. And there have been serious injuries dropping whatever it is that comes out, whether it's water or suppressant of some other kind. Serious injury to firefighters when they're off target, and the wind can cause that shift. So you don't hit your target. Instead, you hit the firefighters that are in the vicinity. Skull fractures, broken bones. I mean, you're dropping tons of water from several hundred feet into the air. By the time it hits the ground, what's still there is going to be traveling 120 some miles an hour.
Which is really ridiculous, right? Because in order to have the amount of force it's going to take to hurt somebody, you have to have a lot of water falling in the same spot.
Right.
Well, how inefficient is that?
I know. A lot of it.
You don't need a lot of water in any one spot. You need water spread out over a distributed area.
That's right.
Otherwise, really, all you're doing is delivering water to the ground, not to the vegetation that's burning.
Exactly. And all the heat that fire is already generating with that dropped water, so much of it is evaporated before it even hits the flames and actually does anything at all to suppress or extinguish. So that's another drawback. Nevertheless, I mean, obviously, it's a useful tool.
Sure.
But we need to look at the whole suite of whatever is out there and some beyond that, your thing and my thing, because we're losing the battle and the whole planet, because of everything heating up, drying up, it's burning up. And I don't think there's any such thing. If we can make any impact at all on the getting an upper hand on the fire situation, we need to deploy anything and everything that offers an opportunity to incrementally improve what we already have out in the field. And it's old stuff. I mean, they're still using pretty much, well, as my brother said, he was in the Marine Corps, 200 years of tradition unhampered by progress. And I heard another retired firefighter say the same thing, and that's kind of what I've seen.
No, it's really true.
Yeah.
I describe it as medieval gardening tools.
Well, you know
Right.
what? I was told one time by a guy I talked to, we had a conversation. He said, so you know what a Pulaski is? I said, I think it's that axe thing, isn't it, with the point on the end of it? He said, yeah. And he said, how about a McLeod? I said, I don't know what that is. And yeah, that's the rake and the hoe thing on back. He said, well, those are firefighting tools. Firefighters invent firefighting tools. So I looked it up, and neither one of those was invented by a firefighter. I think it was around 1912 where a guy named Pulaski took this thing to, he was a volunteer firefighter, and he took that tool, it was actually invented by the Collins Tool Company in 1876. He just happened to have it in his garage or something. He took it with him to the fire show. He showed up at the scene, and all of a sudden this Pulaski, which is still on the firefighting emblem today. And the McLeod is like, I guess that's a really great invention, but these are hand tools that are now over 100 years old. That was 1912 for the Pulaski, and I think it was about the same time period, plus or minus, for the McLeod. So we need to do better. The challenge is
these
out
are
there.
pretty closely related to 15,000-year-old hand tools that we used to cultivate wheat. Right?
Yeah, we could go back to then, I guess, too.
Yeah, right. I mean, really, not much has changed.
No.
And maybe, probably wildland fire control wasn't a big thing then.
Probably not. That's because
given that most fires are human created and there just weren't that many humans.
Well, and nature took care of itself better that way too. I mean, they would let things burn, and we had a very healthy ecosystem before we thought that we were just too good and had to put out every single fire that came up because we could. And look at the situation we've created as a result.
Yeah,
Bad
and
news.
now, we can't go to an opposite solution of just letting things burn because the fuel conditions are very different than they would have been had there been natural burning. Right now, you have this contiguous canopy that goes on for hundreds of miles.
Yeah.
And, that has to be broken up to simulate what natural fire would have done before it can be allowed to safely burn on its own.
Exactly. Too many trees and too much undergrowth. And once you get undergrowth, then you get the ladder fuels, and it won't just stay on the ground. Next thing you know, you got a canopy fire and you burn down the whole forest.
Right. So you said too many trees, and I say also, too many trees. And yet we still hear, you see people wearing the T-shirt, save a tree. Oh, don't use that paper towel. You're using up tree. Oh, don't use whatever. Don't use that cardboard packaging. You're using up trees. We need things to do with the surplus amount of tree material, of cellulose.
We do, absolutely. We need to thin it out, though. The problem is whenever they get the go-ahead to do some log cutting, they just do clear cut.
Yeah.
It's a whole lot more work to get in there and work among the trees and thin them out and leave a lot of the old growth still standing. They want to go in and just, start at the beginning and just cut everything down until they get what they want. And the rest of the forest is still in this terrible condition of too much undergrowth and too many closely spaced trees.
Yeah. And there's, divergent opinions on old growth versus new growth. That once a tree reaches a certain size, it's kind of absorbed the carbon it's going to absorb. And then it's kind of a neutral, a neutral force there. With that seedling, has the potential over the next 30 years to absorb, tons and tons of carbon.
Absolutely. Yeah, I mean, the big trees are still great for carbon storage, no doubt. And we need old growth to maintain that carbon storage. But I mean, I'm not a forest conservationist. I really don't know that much about it. But I do know from just what we've already seen, we all see it, and that is that right now the trees are too dense, and the undergrowth around all those trees is too thick, and it's a recipe for disaster. And we're seeing it every day playing out across the globe. Not just here in the United States. It's a world situation. It's unbelievable.
So have you reached out to people who are most in need of the service right now? Call up to Canada?
Yes. Yeah, I've had some conversations with Canada, but I'm afraid since now the effort seems to be to make it the 51st state, that they've kind of cooled in their reception to what we were seemingly making some progress on. So anyway, we'll have to deal with that.
Yeah, right. I think within the fire community, it's more apolitical.
I think so
But
too. I think the understanding is there. I think the appreciation there is there. Clearly, the wisdom is there. And people who are out in the field, and I've spoken with a lot of just in the field firefighters, a number of them, and they support what we're trying to do. And just innovation. Well, first of all, what has been standard fare for the firefighting community? Change is difficult. It's painful. It can be expensive. But in the long run, I mean, if you embrace the proper new tools that are being introduced now, it's certainly going to be a much more advantageous position. We're not in a good situation right now.
we are
We
not.
need to do better.
Yeah, no, absolutely.
Yeah.
And well, we're hoping that technology, like what we've been investing our life savings in, provides some incremental improvement in the state of the art.
I certainly hope so. I mean, we have to do better. I mean, there's just no way that we can continue doing what we've been doing and expect things to change in a positive way. It's clearly getting worse, not getting better, and we need to introduce new innovation into the field to help the firefighters do the job. The other thing about this too, if you put my machine in back of a crew while they're fighting, keep the heat, the flames, and the smoke away from them. It's a healthier environment, much more conducive to being effective at what they're doing, and just a much better condition under which they can best do their job to fight that fire. So that's another aspect that we hadn't talked about yet, but that's another reality that it's unequivocal about the ability of this device to do that.
And have you thought about its use in hazmat situations? If you're approaching a leaky tank and all of the vaporizing fluids from that tank are going wherever the wind goes, to be able to push them back and let the hazmat crew be able to get in and do a tank repair?
Yes. One of the things that we're looking at is a pool fire. To try to do a pool fire as one of our testing evolutions. I don't know what I mentioned. I guess I haven't mentioned this yet, but the National Science Foundation has invited us to write a proposal, and the proposal was written. Had some issues at first, but finally it was resubmitted on April 25th of this year. It takes about 6 months. But they were concerned about generation of embers. And of course, we have total control over the airspeed. So if even embers start to rise, you cut down on the airspeed, you cut down on the flame height and the fire intensity, and that plume that would tend to lift embers into the air would be subsided and it would come back down. They said they're intrigued with the concept. But a pool fire is one of the things that I have proposed to do as part of the additional testing if we get funded for this grant request. Pool fire, among a bunch of other things, is what I would like to do. Another thing that I see this as a useful tool for would be punching a hole through a flame front. I think we both agree that our devices are probably limited primarily to grass fires and things like that, not forest fires. I think with the high enough targeted airstream flow rate, we can, first of all, bend back the burning fuels back on already burned stuff. So I think we can poke a hole in a flame front wide enough and large enough for a fire crew if they were to get trapped. And more people die fighting grass fires than wildfires to allow them to escape. And that's another thing that we want to test. But the pool fires, like you were saying, for like a truck or an airplane or something like that, trying to sweep away the fumes and try to keep the flames down is something that we want to try to test. And, a lot of the airports that have firefighting equipment to combat this kind of thing use the aqueous foam form film.
AFFF.
Film, to put over AFFF. But that's an environmental hazard, and there are several states that have already outlawed that. So there's an opportunity there too. One thing I'm concerned about is with the high velocity to sweep the fumes away, we might be blowing the fuel around, away as well, and just vaporizing more of it and causing the flames to not be tamped down, but maybe even increase them. So this is just a proposal, and there's something we'll look at. But just throwing a grid down and just roll out this honeycomb kind of thing to keep that kind of sweeping away, and just let the honeycomb thing flow over the spilled fuel, and then apply our airstream, which would probably keep the fuel from getting whipped up into the air. So just a thought. We haven't done it yet.
No, and you said that we're going to need a wide variety of technologies supported by a wide variety of chemistries
Hmm.
and delivered by an enormous realm of hardware,
Right.
right? So like there's plenty, and I never think of anybody in the space as a competitor because I always think there's enough fire for everybody.
Boy,
But but
that's a fact.
yeah, it is.
I wish
But
there
I'm
weren't so
curious.
much, but there is.
Yeah.
Yeah.
So I'm curious about the impact that entering this space has had on your social circle. Like,
Uh,
do you
well,
have friends now that you didn't have before because you're,
yeah, I
in
do.
this space so much?
Yes, a couple of fire ecologists, fire research scientists, a couple of professors, different universities, um, and like I said, some of the in the field firefighters, people that I probably would never have had an occasion to sit down and have a chat with. But uh, there's an interest, and of course, we need to do more proof of concept. You're much further along than I am, but I think it's there. I think the opportunity is there to do just that. And there have been a lot of people who have expressed interest to attend whatever testing that we might be able to do, hopefully in the near future, to allow them to take what they have witnessed, nothing like seeing something rather than just talking about it. Take that back to their people and start having a conversation about the utility of this type of approach to fighting fires.
Yeah. Well, I'd love to get us jointly out on a large prescribed burn, maybe on a military base or something where
Yeah, I've reached
put these machines.
out to people in Texas, Oklahoma, Nebraska, Kansas, and of course New Mexico, where I live. Um, Here we are. You know, there is a certain risk. There always is. Whenever you're actually setting something on fire, it's not as if you're guaranteed of the results. But I think that with this kind of tool, for something to totally get out of control, of course, if the wind's howling already naturally, you'd be stupid to try to do anything. But there are so many conditions where everything is just right, but they don't have wind, or they have too much wind.
Hmm.
And too much isn't really a whole lot. It's like maybe I think 10 miles per hour, something like that, and they don't want anything more than that when they're doing a dry burn. We could counter that without any problem at all. And
Yeah.
my idea would always be to have at least one propagating the flame front, and ideally have people on the flanks. So if the wind did shift, because I've seen a shearing wind surprisingly just in a wink of an eye change the direction of the fire propagation. But if we had these things mounted on the, not mounted, but placed at the flanks of the same propagated flame front, we can protect against that. Flame fronts aren't so deep that this thing can be overwhelmed by the length of the flame front. I think a maximum flame front for a grass fire is about 15 feet. That's not
Yeah.
a big challenge. That can be handled.
No.
So, yeah,
We'll get out there and we'll try.
we have to keep trying.
Well, I'm going to spend this week looking for live fire opportunities, be they prescribed or people who say, we got nothing to lose at this point.
Private
We're
owners.
about to lose these cities anyway.
There you go.
Right. These are, you could think of these much like terminal patients, right?
Yeah.
Like, hey,
let's try something, anything.
Right. The end is in sight anyway. We got nothing to lose to try this.
Exactly.
Yeah.
I do have a website. It's not anywhere near as cool as yours, which is excellent, by the way. Congratulations on that. But it's just openinnovationllc.com. And
Open Innovation LLC.
.com. Yeah, that's
.com.
the website.
Awesome.
So I welcome anyone who might be listening to have a look. There's some comments made by various people about how they view the potential of this device. The testing that we did do at Tall Timbers is there. Brief, but It's definitive, I think, in my mind anyway, hopefully in others as well. But that's where we are. We'll keep adding to it as we continue to get more testing. Hopefully we'll get the National Science Foundation grant, but we'll see about that. They're cutting the funding, and I actually used the term climate change twice, and I understand they're...
Oh, that's it. You're done.
That could be it. I mean, I wish it were only a joke, but I think it could very well be a truth. We'll see.
Well, yeah, first of all, that's just sad off the face of it. Second of all, I think that the people who are afraid of the term climate change are really more of climate change attribution. Like, don't say it was because of our industry, or don't say it was because of this, or don't. But the data itself is not disputable. That the temperature, the wind speed, the humidity are different than they were.
Yes.
So,
Yeah. No, all you have to do is look at the data and keep an open mind about what you're looking at. It's there if you want to find it. And if you want to hide from it, you can do that too. And unfortunately, there's too much of that going on, I think.
I don't mind the people who hide from it so much as I mind the people who hide the data from other people.
We're hiding it, yes.
Right.
Absolutely.
Like demanding the purging of hard drives with, Anyway, we don't have to go there because we can have much more influence by working on the things we're working on than on the things that are upsetting us at night.
We have to do what we can. I mean, that's what we're both trying to do. We recognize the need. I think others do as well. And we want to complement what is already out there for the firefighter safety and the effectiveness of being able to fight fires that are out there.
We'll get there.
I hope so.
We'll get there. Wayne Darnell, thanks so much for joining me on the podcast today.
My pleasure. Thank you very much for the invitation.
Absolutely. You've been listening to Wayne Darnell. Check his website out, openinnovationllc.com. Some really interesting technology there, using the force of air alone to manage, direct, and control the growth of wildfires. Really cool stuff. You've been watching the Fire Break. I'm Steve Wolf. We're sponsored by Team Wildfire. Until next time, have fun, be careful, and do some innovation.